Welcome back. This lesson takes us to the end of Chapter 9, where we look at division with fractions. We'll see three ways to make sense of division with fractions, using pictures, using area, and the invert and multiply rule. Alright, so how about using pictures? One serving of beans is 3/4 of a cup. How many servings can I make out of 5 cups? A lot of times when you do division with fractions, it's this how many groups model. It's sort of a measuring model where one thing goes into another. How do you think about that in this problem? What is going into what? Well, one serving of beans is 3/4 of a cup. How many servings can I make out of 5? So the total is 5, and I want to know this 3/4. How many times does 3/4 go into 5? 3/4 into 5 means that my problem is 5 divided by 3/4. I have 5 cups. Let's say 1, 2, 3, 4, 5. Somehow those are 5s. And I need to know how many times 3/4 goes into this. So what that means is I'm going to have to divide each cup into fourths so that I can see it more clearly. And now I'll start counting the 3/4. 1, 1, 1. That's one serving. 2, 2, 2. That's another serving. 3, 3, 3. 3 servings. 4, 4, 4. 5, 5, 5. 6, 6, 6. Oh, and then I have 2 squares left over. So the 6 represents 6 servings. So in terms of servings, how much does the 2 squares represent? One serving is 3/4. So 2 of those means with 2/3 left over. 6 servings plus 2/3. So I could say 6 and 2/3 servings. And there's my solution. How about this problem? One bag of fertilizer covers 2/3 of an acre. How many bags are needed to cover 10 acres? So let's say I need the number of bags. So bags into the total acres. So I need to take my 10 acres and divide by 2/3. How much does 2/3 go into 10? Each acre needs to be represented as 3 of something, so I can take 2 of it to represent 1 bag of fertilizer. So let's just say 3 dots in a row, 3 circles in a row. That's 1 acre. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've drawn a picture representing my 10 acres. And I've made each acre 3 parts so that I can represent 2/3 of an acre. Okay, so now I'm ready to start identifying bags of fertilizer. There's 1 bag, so it's 1, 2, 3, 4, 5, 6, 7, how about this? 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 exactly. So 15 bags is the solution to this problem. How about the area model? Use area to solve this division problem. This is often useful when I have numbers that are small, less than 1. And the strategy is to draw 1 by 1 square, convert to multiplication. So we'll see how this works. Remember, multiplication can be thought of as multiplying a length times a width to get area. So 8 15ths divided by 2/3 equals something. How do I change that into multiplication? 8 15ths equals 2/3 times something. All right, and 8 15ths is going to represent an area, and the 2/3 and the something are going to represent lengths. So I have one length that I know, 2/3. So let's take one side of my square and represent 2/3. So there's 2/3. And let's just divide this whole unit square up into 3 parts. So I'm imagining that this square is 1 by 1. Now, the inside, the area that I need to make, is 8 15ths. So that 15 on the bottom, 15, that means that this whole unit square must be divided into 15 equal parts, 15 equal little rectangles. Well, let's see. If I have 3 going this way, that means I'll need 5 in the other direction to make my 15 parts. So let's divide into 5 rows. So I think something like that should work. So now I've made 15 rectangles, and I want 8 of those 15 rectangles. So I'll do that above my 2/3 that I made. Above the 2/3, I need to make 8 of those 15ths. So there we go. So here's a rectangle that contains 8 of those 15ths. 1, 2, 3, 4, 5, 6, 7, 8. Yep, there's 8 of them. And what is the dimension on this side? That dimension looks like 4 parts. 1, 2, 3, 4 out of 5. So 4/5. So 8/15 is the 2/3 times 4/5. And now I can recover my original division problem. 8/15 divided by 2/3 equals 4/5. Let's do one more problem like this. Here's the problem. Use area to solve 6/20 divided by 2/5. I encourage you to pause the video for a minute and see if you can solve this. And then when you're ready, unpause it and let's see what the solution is. All right, so I will draw a 1x1 square this way. I'll change my problem into 6/20 equals 2/5 times something. I will make 2/5 in one dimension. So that means I need to divide my square into 5 parts. Here's 2 of those parts, that's 2/5. But now the solution needs to have 20 parts altogether. So this whole square needs 20 rectangles. So I've got 5 in one direction, which means I need 4 in the other direction. So 5 times 4 is 20. Okay, so I've got my 20 equal parts. And now I need 6 of those parts. So in order to make 6 of those parts, it looks like this is the kind of rectangle I'm focusing on. And the dimension of the other side of that rectangle is 3/4. And so my original division, 6/20 divided by 2/5, that has a solution of 3/4. So the basic idea of area is I can convert a division problem into a multiplication problem and then just think about multiplication in terms of area. Our last tool is the invert-and-multiply rule. I will not give really any meaning behind this, but it's just a procedure to solve a problem. So 4/5 divided by 7/3, the invert-and-multiply rule says, take that second fraction, the one you're dividing by, the 3/7, invert it, so that becomes 7/3. Oops. And now I want to multiply that. So 4/5 times 7/3. Multiply across the top, 28. Multiply across the bottom, 15. And there's the solution. My tractor used 3/4 of a gallon to travel 4/5 of a mile. How many miles per gallon does my tractor get? The per tells me division, so miles divided by gallons. Let's say I have 4/5 of a mile, and I'll divide by 3/4 of a gallon. So miles per gallon, 4/5 divided by 3/4. So I can invert the 3/4. I get 4/5 times 4/3 equals 16/15. And there's my solution, 16/15 miles per gallon. All right, those are the basic ideas. Give those worksheet problems a try. Don't neglect it. Try your best. Look at the answers. Check your work on that. And I look forward to seeing your work. Be sure to ask if you have any questions.